Hey y'all, if you noticed, this week's worksheet looks a lot like last week's worksheet. There were some steps on top and 6 problems. Last week I did example 1 and in the video, and then I did example 4 in the video, and that was it. And I said, go ahead and work the rest on your own, and then look at the completed note sheet for the rest of the solutions. And that's because the remainder of the problems are real similar to the ones I had worked in the video. Well, this week we're going to do all the practice problems together because there's slight variations in each different problem that I want to talk with you about. So what we're going to do is I'm going to work each problem, and you just pause the video between each problem to give yourself some time to try the next problem on your own before you watch me work it and talk about it, okay? So that's how this week is going to look different from last. So as a quick recap, the 2 topics we covered last week were multiplying radicals without variables, multiplying radicals with variables. This week we're still working on multiplying radicals, but we're going to be folding in the distributive property. Today we're just going to be doing the distributive property once, and the next lesson for the week we're going to be doing distributive property twice. Sometimes in class I call that double distributive. You probably are mostly familiar with hearing it called FOIL, but that's for the next lesson. Today we're just working on a single distributive using radicals. So here are the basic steps. Step 1 is to distribute the radical that's outside the parentheses. Step 2 is to simplify the radicals. That's where you take your factor trees and you look for your groups to simplify. Like a square root, you need groups of 2, cube root, you need groups of 3, etc. And then on the last step, this will be new from, this is a new addition from last week's lesson. You combine like terms. So here's where we have to keep the rules for multiplying and separate in our mind from addition or subtraction. Last week for multiplying radicals, we said that the roots have to be the same, but the radicand, what's underneath the root, does not have to be the same. But when you go to, and that's for multiplying, but when you go to combine like terms, this means you're either adding or you're subtracting. This, from previous lessons, we remember like terms have to have the same root. That's just root. And same radicand. And so I'll be talking about that while we're working. So to multiply, they can be different under the root, under the radical sign. But for adding and subtracting, they have to be the same under the radical sign. So here we go. Problem, example 1. So we are going to distribute the radical that's on the outside. And so remember, when you're multiplying radicals, you multiply the outsides and the insides together. There's actually nothing on the outside of these radicals, so we know it's really just 1 everywhere. So when we multiply the outsides, we still get 1. We multiply the insides, and we have 12. And then when I multiply the 6 times the 18, I get 108. All right, so there's step 1. Step 2 is to simplify the radicals. You can do your factor tree and write everything out long and then find groups of 2's because we're doing square root. But I'm going to do the ninja method and just skip to the perfect square method. I know that 12 is 4 times 3, and 108 is 36 times 3. Again, if you're not comfortable doing that ninja method, you can do, like, instead of 36 times 3, you can just do a long factor tree, which would look like this. 2 times 2 times 3 times 3 times 3. That would also give you, that's the square, that's also 108 broken down. So here, the square root of 4 comes out as 2, and then 3 is left over inside. The square root of 36 comes out as 6, square roots of 3. So the last step says to combine like terms. So here's where you have to check if the radicands are the same. That's the stuff inside. Are they the same? Yes, that means we can combine. So I have 2 roots of 3 plus 6 roots of 3. I have 8 root 3's altogether. Okay. So I want you to pause the video and try number 2 on your own. Okay, so number 2, you should have distributed the radical 6, and that would have given you square root of 6 plus 3 square roots of 36. Okay. When you distribute square root of 6 to the second term right here, remember there's a 1 out front. You do the 1 times the 3 and you get this 3. And then inside you do 6 times 6 and you get 36. So now you simplify if possible. We cannot simplify the first one. So it just stays rad 6. But the second one, the square root of 36 is 6. So the radical goes away completely, and it's being multiplied by that 3 out front. And so now we just do that math. So I have rad 6 plus 18. I cannot combine those. They're not like terms because the 18 doesn't have a radical 6 attached to it. So we're just done right there. So that's what it looks like when they're not like terms. You just leave them alone. Pause the video now and try number 3. So you should have distributed square root of 8. And now I've got a radical times a whole number 2 out front. That 2, you just smush it in front of the radical 8. So it's 2 radical 8. Because it's really like there's a 1 out here. So 1, you're multiplying what's outside the radicals. 1 times 2 is the 2 there. So 2 radical 8 minus 5 radical 64, because you do the 8 times the 8, what's on the insides. Now both of these radicals can be simplified this time. 8 can be rewritten as 4 times 2, where 4 is a perfect square. And then minus 5. Now all of square root of 64 simplifies to 8. There's no radical left. So then the next thing I'm going to do is the square root of 4 here comes out as 2 times this 2 that was already out front. And then the 2 that's left inside. That's a lot of 2's. And then 5 times 8 is 40. Okay, almost done with this problem. We have a little more multiplying to do. These 2's outside, multiply those, you get 4 rad 2 minus 40. And those do not combine because they're not like terms. If this 40 had had a radical 2, then they would be like terms and we could subtract them. But it does not. So colors must match. So there's our answer there. All right, so each of those had a little bit of different flavors to them, which is why I worked all of it out on the video for you. This next section has similar characteristics to the ones we just did, but look at these problems and take a second to figure out what's the main difference in these problems and the ones we did above. All right. Babe, I'm recording a video. So hopefully you notice that these were cube roots instead of square roots. So take a minute and pause the video and do number 4. So you should have distributed that cube root of 9. So we've got 5 cube roots of 9 minus the cube root of 9 times 18, which is 162. Now you might really very strongly want to say that this simplifies to 3, but it does not, right? The square root of 9 is 3, but what's the root here? Cube root of 9. So if you break down 9, you just get 3 and 3. But when you're trying to take a cube root, you're looking for groups of 3 things. There is no cube root of 9. So this does not simplify. There's no group of the same number that occurs 3 times. Here's what I'm trying to say, sorry. There's no number times itself 3 times, which gives you 9. Therefore, this does not simplify. But in the next radical, 162, there is a perfect cube in there, and it is 27. Again, if that isn't something that comes quickly to you, you don't have to do that ninja style. You can just do something like this. You can do your factor tree, and your factor tree would have given you 3 times 3 times 3 times 3 times 2. And you would have found this group of 3's that comes out, and this would have stayed inside. Okay? So the next step looks like this. The 5 cube roots of 9. This cube root of 27 comes out as one single 3. And then the cube root of 6. These do not combine. Their roots are the same, but their radicands, stuff inside the radical, are different. So you're done. This is your answer right here. 5 cube roots of 9 minus 3 cube roots of 6. Pause the video and try the next problem. All right, next problem. Distribute, distribute. In the first distributive, there's no radical on that -2, so it's just -2 times the 1 in front of the outside radical. So that's -2 cube roots of 4 minus the cube root of 24. So looking at the first term, we cannot simplify that radical. There is no number times itself 3 times that goes into 4. So this just stays how it is. But in the second term, there is a perfect cube in 24, and it is 8. So then the next step looks like this. The cube root of 8 is 2, so we bring that outside. So -2 cube roots of 4 minus 2 cube roots of 3. And we cannot combine, we cannot actually do that subtraction because their radicands are different, the 4 and the 3. So we're just done here. All right, pause the video and try the last problem. So distribute, distribute. I've got negative, there's a negative outside this radical here. Negative cube root of 27 minus the cube root of 18. Now right here in this first term, the cube root of 27, this is a perfect cube. So just like when we do square root of 4 is 2, and the radical is all gone because it's perfect, this one is just like that. The cube root of 27 is just 3, and the radical is all gone. And then on cube root of 18, there's no perfect cubes in 18. If you did the factor tree there, you would have 3 times 3 times 2. There's no group of 3 in there. So we cannot simplify that. It just stays like this, and there's my answer. Okay, please upload a picture of your final work up to your Google Classroom for the daily grade.